Woohoo! Welcome back. Today we're going to be working with buying a house. Woohoo! Congratulations! We are buying our dream home, which was going to cost us $800,000. I'll just look in my pocket for a little change. The way we're going to buy it is we're going to put $50,000 down, which means we're going to take $50,000 that we've saved up and pay directly for the house with that. And then we're going to amortize the rest of the debt with monthly payments over the next 30 years. This is going to be exciting. If the interest on the debt is 5%, compounding monthly, find the following. The size of the payments. Woohoo! So what we did in the last video was to look at the amortization formula, which is right here. And the amortization formula is basically based on the fact that we're going to be making repeated payments to pay back a loan for a loan value that is evaluated now. So it's not a future value, it's a current value, and that's called amortizing a loan. My Sharky friend is here to help us with the loan, so to make sure we get everything just right. And you will definitely need a calculator of some sort because these are not easy problems to do in your head. Okay, woohoo, yay! So the first thing we want to do is we want to find the size of the payments. Now again, this is the amortization formula. R is the size of the payments. So we're going to need to know A, the present value of the loan, I, the interest rate per period, and N, the number of payments. So let's go ahead. I'm going to move this to the side. We'll bring it back in just a little bit. So first off, we need to know the loan amount. It's very simple to think, okay, well, it's just 800,000, but it won't actually be 800,000 because we're going to make a down payment. So it's actually going to be $750,000. So the good news is that that down payment is going to save us a lot of interest. The bad news is that it's not easy to come up with a down payment, but congratulations, we managed it. Woohoo, yay. Okay, so we're going to get a loan for $750,000. The next thing we're going to need to know is the number of payments and the interest rate per period. So again, the interest rate is R over M, which in this case is 0.05 divided by, and we've got, this is monthly. So let me see, let me grab a handy dandy highlighter. Because we're compounding monthly, right? So we're looking at monthly. So because of that, RM is going to be 12. Now, it turns out that this is an ugly, well, you may think it's beautiful, but it is a repeating decimal. It's not nice. So we're going to use it in this form. It's not a good idea to round. If you round your I, all of your numbers will be off. So we need to make sure that whenever we need to use I, we use its full expression like this. So do not use an approximation. Now N, the total number of payments, is going to be, let me see, I've got this, 30 years. So 30 years, let me write this twice. I know that looks weird, but there is a method for my madness. Times 12 times per year. So in other words, we need to know the number of years times the number of times per year. This is going to be 30 times 12, which is 360. This is really common. Having 360 payments for a mortgage is really common. The other one is that you have a 15-year loan, so that would be half of that, or 180 payments. Now, one note about this is when we do these problems, we approach it from a mathematical perspective. And so we're going to be looking at 360 equal payments. In reality, when you actually buy a home, the first 359 payments are regular payments. And then the last payment is usually a little bit different, just to account for rounding and, all the little other things. So the last payment is not always equal, but for us, we're just going to do these as if all the payments will be the same. Okay, now I need my amortization formula. Let me see if I can kind of scooch this so that you can see that. Okay, so we've got R equals our loan amount, which is $750,000, times, and again, I is going to be this whole expression, 0.05 over 12. And then in the denominator, 1 minus 1 plus 0.05 over 12 to the negative 360. Okay, so hopefully the formula is pretty straightforward. By this point in the chapter, you've been working with these formulas, so hopefully they're starting to feel more familiar. But again, as always, if you have any questions, talk to me, ask me questions, message me, send me email, talk to the tutors, get help, because that help is available, right? These problems are not easy, so reach out and let us help you work out how to make this work for you. So the next step is going to be a little tricky to show you, because at this point, there are some people who are going to be using, a traditional calculator. Some people are going to be using their cell phones, and the little calculator comes in the cell phones, and some people are going to be using something like Google Calculator or another browser or online-based calculator. So there are actually a lot of different ways of doing this. So I'm going to do my best at showing you the steps. So the 750,000 can come at the beginning or the end. It's up to you. So I'm going to take 750,000 and I'm going to multiply it times, and I'm going to just multiply across the top. So 0.05, and then I'm going to divide that by 12, and then I'm going to hit equals, or if you have an enter, use enter instead. Now this will give me the amount across the top. And if you are prone to making mistakes, you may want to store this in the memory of the calculator. It's up to you. So this is the numerator. And then we're going to go ahead and continue. I'm going to divide it by, and then I'm going to put in parentheses, because I want this whole expression to be in the denominator. So I'm going to open a parenthesis, and I'm just going to follow along. 1 minus, and then another parenthesis. That's this parenthesis right here. So let's see, do I have another color that I don't mind using that I can grab? Oh no, here, I've got a green. So this parenthesis right here is this parenthesis right there, if you can see that. Hopefully that helps a little bit. Then I've got 1 plus. Now, here things get a little tricky. Most calculators will allow you to do this 0.05 divided by 12. And then I'm going to close the parenthesis. And the great thing about most scientific calculators is they will know to do the division before the addition. Calculators do know order of operations. Now, your cell phone might behave a little bit weird, so try it out. And if you have trouble, if you find that it's giving you funny answers, reach out. We'll help you figure out how do you use your calculator. Now, next up, if you have some calculators, you're going to be looking for a key that looks like this. That's the exponent key. Or you may have an x to the y key or a y to the x. And then you're going to use the opposite key. Now, there are a couple ways that this looks. Sometimes, like on this calculator, it looks like a minus inside parentheses, and sometimes it looks like a plus or minus. You have to change the sign, and then 360, close the parenthesis. These two are the ones that go together there. Let's see, the risk of doing too many colors. These parentheses are the ones that basically just keep the whole denominator together. Here's the other green one while I'm at it. So this is how you would do it on this calculator. Again, your calculator may do some funny things. For example, sometimes these two, the changing the sign and the 360, need to be done in the other order. Okay, so let's see if I can get through this. Fingers crossed. So let me turn it on and get it out of the glare. Okay, so I've got 750, 1, 2, 3. So 750,000 times 0.05 divided by 12 equals, so for the top, for the numerator, I get 3125. Now I'm going to go ahead and divide by, open a parenthesis. I've got 1 minus, open a second parenthesis, 1 plus 0.05 divided by 12, close the parenthesis, raise, here I'm going to raise it to the opposite of 360, close parenthesis, and hit equals, and I get, dun dun dun, 4026.162 and some other stuff. So this is going to be approximately 4026.16. Now, remember what I said about the last payment. So in fact, to pay your mortgage, you have to pay this much exactly. We're going to be paying slightly less than that. So that means that the last payment will likely be a little bit higher to take into account all of those extra little bits. Or it could be that your bank automatically rounds up. So you might be paying 4026.17 instead of 0.16, so that it captures that little extra bit there, and then at the end of your loan you pay slightly less for the last one. So that's in the real world. Your last payment will be slightly different. For us in the math world, we just say, you know what, it'll be this much. Okay, we got it. That's your monthly payment. That's a lot in my mind, but you know, hopefully we can afford it so you can have your dream home. So what's the total amount of the payments? There are two ways to answer this. Officially, if you have this amount and the calculator knows more digits than it's telling you, all you have to do is multiply 360 times 4026.162 ... And so if I multiply by 360, we get, can you guys see that? You can't quite. $1,449,418 and 38.2 cents. Now, we've talked about the fact that in the real world, this would be slightly different because your last payment would not be exactly equal to this. So this is the assumption that every payment is the same. So it's a little bit different than the real world just for the math class. If you want to, though, we could look at a rounded version. The rounded version would be 360 times 4026.16. So you could look at the actual payments, and that would be slightly different. 4026.16 times 360 equals 1,400,000, sorry, you can't quite see it, $449,417.60. And you can see it's slightly off because of that one, the 0.2, etc. cents over at the end. So, and sometimes WebAssign would like the unrounded amount, and sometimes they want the rounded amount. And if you're ever curious which one the homework wants, just let me know. I'm happy to help you figure that out, because sometimes the instructions are not great on the online homework. Okay, what is the total amount of interest paid? Well, obviously, it's a lot of interest, right? The loan amount originally was $750,000. So depending on whether you go with the rounded, hello loan shark, there you go. And depending on whether you're using the unrounded or the rounded amount, you're still going to have a significant amount that you've paid in interest. So unrounded, $1,449,418.38.2 minus $750,000 will give you one thing, and the rounded amount, $1,449,417.60 minus $750,000 will give you a slightly different amount. That's the amount I have right here. So I'm going to go ahead and I'll do the second one first. Minus $750,000. So you're actually paying almost $700,000 in interest. So this is why banks, oops, you can't quite see it, sorry about that. This is why banks like giving out mortgages. If they can find someone who will consistently pay them over the life of this loan, they're going to make $699,000 in interest off this one loan. So it basically doubles their money almost. Okay, let's go ahead and let's see what this one would be. 1,449,418.382 minus 750,000. This one would be slightly different. And again, this has to do, the problem is that this book doesn't always explain exactly what it would like for its answers. So sometimes the answers will match one or the other. So this is just to let you know. Sometimes it's rounded, sometimes it's not. And again, if you're ever just having a frustrating time with it, please reach out to me and I will take a look. Much like the frustrating time I'm having with this paper, reach out to me and I'd be happy to help you with it. But that's it. We've just calculated, there you go. That's the mortgage on a home loan. This is exactly the method we would use to work out the size of the payments if you're looking at a car loan. I'm going to guess that the car you're buying is not $800,000, but maybe you found a really cool $800,000 car, and this is how much it's going to cost you per month. But usually cars are a little bit less expensive, but this process would be exactly the same. So there you go. Woohoo! We just bought a house thanks to our friendly neighborhood loan shark. And I hope this has been very exciting and educational. And I hope you know how amazing and incredible I think you are and how brilliant you are. And please take your brilliant brain and go rest it. Go do something fun. Look at something green. Get away from screens. Do something else for a little bit just to let your brain relax, let your eyes relax. And then I will see you in the very next video. Woohoo! You guys are awesome. Take care. Woohoo, and math on.